get some definitions before we continue. Let A be a square matrix. Then the minor, denoted by Mij, or the element Aij, is the determinant of the matrix obtained by deleting the ith row and jth column of A. So the minor itself is going to be a matrix. That's why I used capital M, and was actually going to be a determinant. So determinant would be related to the matrix. So I'll find the Aij element, and we delete the ith row and the jth column. What's left would be the minor. Now the cofactor, Cij, is given by Cij is equal to -1 to the I plus j times the minor. So the cofactor has the -1 multiple. And notice the -1 to the I plus j is just going to alternate signs. If I plus j is odd, then -1 to an odd power is negative. If I plus j is even, then -1 to an even power is positive. So this would just be to alternate the signs. Let's look at an example. Let's look at the matrix 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. We have a square matrix that is 4 by 4. 4 rows, 4 columns. So it's a square matrix. And we want the cofactor of 7. Well, to find the cofactor of 7, first of all, the cofactor is going to have a -1 power. And it's going to be -1 to the I plus j. That's row plus column. Well, 7 is in the second row and the third column. Times the minor, Mij. Well, the minor is going to be the matrix with the row involving 7 and the column involving 7 removed. So, take the row involving 7 and remove it. Take the column involving 7 and remove it. And what you have left is the minor. So the minor is going to be 1, 2, 4, 9, 10, 12, 13, 14, 16. So I wanted to show you how I did it. You might have a hard time reading the writing. I had to do it real small. So in case you can't get it, here is the cofactor in print. It's the -1 factor times the determinant of the matrix with row I, column j omitted. So I took out row 2 and column 3. Took out row 2, column 3, and what's left gives me the cofactor. Along with this part is called the minor. The whole thing is called the cofactor. we're going to use minors and cofactors to evaluate the determinants of square matrices. If A is a square matrix of order 3 or greater, then the determinant of A is the sum of the entries in any row or column multiplied by their cofactors. So this is one way of evaluating a square matrix. So for any square matrix of order 3 or greater, now if it's of order 2, then of course you just do the main diagonal minus the other diagonal. But if A is a square matrix of order 3 or greater, then the determinant of A is the sum of the entries in any row or column multiplied by their cofactors. Let's evaluate the determinant of the matrix 1, -1, 0, 3, 2, 1, 1, 5, 1, 3, 0, 2, 3, 4, 2, -2. Now to evaluate it, we can pick any row or column, and then we can sum the products of each entry times its cofactor. So pick any row or column and then sum the products of each entry times its cofactor. So we add up the results of each entry times its cofactor. Now I can use any row or any column I wanted to, but notice that column 3 has 2 zeros. We know 0 times anything is 0. I am going to be doing each entry times the cofactor. So 0 times the cofactor would be 0, 0 times the cofactor would be 0, so it just appears to be easier to pick column 3. So I'm going to pick column 3, and I'm going to multiply each entry in column 3 by its cofactor, and then sum the results. So the first entry we have is 0, so it's going to be 0 times its cofactor, which would be -1, and this is in row 1, column 3, so it would be 1 plus 3 times the determinant of the minor. So what I do now is to remove row 1 and column 3. So I'm left with 2, 1, 5, 1, 3, 2, 3, 4, -2. Plus now, I go to my second element, which is 1, -1. Now that's row 2, column 3, so it'd be 2 plus 3, row 2, column 3, times the minor. Now this time I take out row 2 and column 3, and we have 1, -1, 3, 1, 3, 2, 3, 4, negative 2. Okay, plus now. I'm going to the next entry, which is 0 to the negative 1, and that's going to be row 3, column 3. So that would be 3 plus 3 times the minor, which would be the determinant with row 3 and column 3 removed. So it'll be 1, negative 1, 3, 2, 1, 5, 3, 4, negative 2. Plus now, I go to my last number, which is 2, negative 1 to the row 4, column 3. So it'll be 4 plus 3. And this time I'm going to remove row 4 and column 3. So we have 1, negative 1, 3, 2, 1, 5, 1, 3, 2. Now we can go back and look. All this is 0. So I'm going to have 0 plus. Now negative 1, 2 plus 3 is 5. Negative 1 to the 5th is negative. So that's plus, I'm just going to say a negative 1, times the determinant 1, negative 1, 3, 1, 3, 2, 3, 4, negative 2, plus 0, plus a negative 1, plus 2 times a negative 1, because a negative 1, 4 plus 3 is 7. That's going to make it negative 1 to the 7th is negative 1. I've got the 2 times the negative 1 then, times the determinant 1, negative 1, 3, 2, 1, 5, 1, 3, 2. So it's going to be negative 1 times the determinant 1, negative 1, 3, 1, 3, 2, 3, 4, negative 2. All that's 0, plus a negative 2 times the determinant 1, negative 1, 3, 2, 1, 5, 1, 3, 2. So now I have to, in essence, evaluate 2 3 by 3s. So multiplying by the cofactor and summing the results only got me down from a 4 by 4 to a 3 by 3. Well, now I've got to evaluate the 3 by 3, so I can pick any row or column and multiply by the cofactor. So to do this one, it's going to be negative 1 times, and I'm just going to go across the top since all of them are about the same, so it's going to be 1, negative 1, row 1, column 1, 1 plus 1, times the minor, which is the determinant with row 1 and column 1 removed. So I'm not going to put the paper down. I'm just going to say we're taking out row 1, column 1, so it leaves me with 3, 2, 4, negative 2. Plus a negative 1 times a negative 1 to the row 1, column 2, 1 plus 2 times the determinant with row 1, column 2 removed. So that would be 1, 2, 3, negative 2. Plus 3 times negative 1, row 1, column 3, times the minor with row 1, column 3 removed. Be 1, 3, 3, 4. Now that's just the first one. Now we need to do this one. And I'll pick row 1 again, so it's going to be negative 2 times 1, negative 1. Okay, that's row 1, column 1, so it'll be 1 plus 1 times the determinant if I take out row 1 and column 1. So it leaves me with 1, 5, 3, 2. Plus negative 1 times negative 1. Okay, that is row 1, column 2 times the determinant. If I take out row 1 and column 2, I'm left with 2, 5, 1, 2. Plus 3 times negative 1 to the row 1, column 3, 1 plus 3 times the determinant. If I take out row 1, column 3, I have 2, 1, 1, 3. This is going to equal to a negative 1 times, okay, negative 1 to the 1 plus 1 is positive 1. Positive 1 times 1 is 1 times, to do this, it would be 4 times, cross multiply this way, 3 times negative 2 is negative 6, subtract, 4 times 2 is 8. Plus a negative 1 to the 1 plus 2 is negative 3. Negative 1 to the positive 3. Negative 1 to the third is negative. Negative times negative is positive, so that would be 1 times 1 times negative 2 is negative 2, subtract 6. One plus 3 is 4. Negative 1 to the fourth is positive 1. 3 times 1 is 3. Times 1 times 4 is 4. Minus 3 times 3 is 9. Minus 2 times, that would be negative 1 to the square, which is positive 1 times 1 is 1. 2 minus 15. Negative 1 cubed is negative 1 times negative 1 is positive 1. That would be 4 minus 5. Negative 1 to the fourth is positive 1. 3 times 1 is 3. And that was going to be 6 minus 1. So this is going to be a negative 1 times, okay, negative 6 minus 8 is negative 14 times 1 is negative 14. A negative 2 minus 6 is negative 8 times 1 is negative 8. 4 minus 9 is negative 5 times 3 is negative 15. Minus 2 times 2 minus 15 is negative 13 times 1 is negative 13. 4 minus 5 is negative 1 times 1 is negative 1. 6 minus 1 is 5 times 3 is 15. So I have a negative 1 times 14 and 15 is 29 and 8 is 37, so that would be a negative 37. Minus 2 times negative 13 minus 1 is negative 14, plus 15 is 1. So it's a positive 37 minus 2, which would be 35, is the answer to the determinant. Let's look at another one. I can pick any row in any column to expand around. I'm going to pick row 2. So it's going to be 1 times negative 1. Okay, that is row 2, column 1. 2 plus 1 is 3. Times the minor, which is what you have left when you take out row 2, column 1. So that would be 2, 5, 3, negative 2. Plus 2 times negative 1 to the row 2, column 2, that would be 4. If I take out row 2, column 2, I'm left with negative 3, 5. 4, negative 2. Plus 1 times negative 1 to the row 2, column 3. 2 plus 3 is 5. And if I take out row 2, column 3, I'm left with negative 3, 2, and 4, 3. So this is going to be a negative 1 times 2 times a negative 2 is negative 4 minus 15 is a negative 19. Negative 1 to the 4th is positive 1. 2 times 1 is 2. Evaluate this determinant. Negative 3 times negative 2 is a positive 6. 6 minus 20 is a negative 14. Minus 1, because negative 1 to the 5th is negative. 1 times negative 1 is negative 1. Negative 3 times 3 is negative 9. Minus 8 is negative 17. It's going to be a positive 19 minus 28 plus 17. 19 minus 28 is negative 9. Negative 9 plus 17 is positive 8. So the value of the determinant, negative 3, 2, 5, 1, 2, 1, 4, 3, negative 2, is 8. I'm going to leave it for you to pick another row or column, expand it, and see that you get the same answer of 8. A 3 by 3 determinant can be evaluated as follows. Whereas for a 3 by 3, we can shorten the steps a little bit and make it more mechanical. Now this only works for 3 by 3. What you can do, you can recopy the first two columns. -3, 1, 4, 2, 2, 3. I recopied the first two columns. Now again, this procedure only works with a 3 by 3. And I'm doing the same determinant that we did last time, so it's the same one. I'm just showing you a different process. And I hope we get 8 as the answer. Now for the 3 by 3, once you recopy the columns, you can simply multiply this way. -3 times 2 is -6, times -2 is +12. 2 times 1 is 2, times 4 is 8. 5 times 1 is 5, plus 3 is 15. Now as we go the other way, now we go up this way and reverse the signs. 4 times 2 is 8, 8 times 5 is 40, so it's going to be minus 40. 3 times 1 is 3, times a -3 is -9, reverse it, it would be plus 9. -2 times 2 is -4, times 1 is -4, reverse it, it would be plus 4. 12 plus 8 is 20. 20 plus 15 is 35. 35 minus 40 is -5. I'm losing count of it, so it'll be -5 plus 9 plus 4, which is -5 plus 13, which is 8. So again, we've got the same answer. Now, of course, as you can see, this process is considerably shorter, but only works with a 3 by 3. Now there is an easy way of doing a triangular matrix. If A is a triangular matrix, then its determinant is the product of the entries on the main diagonal. Now a triangular matrix is a matrix that either has all zeros below the diagonal or all zeros above. In other words, if it's either upper triangular or lower triangular, this process works. So if A is a triangular matrix, then its determinant is a product of the entries on the main diagonal. So this determinant is just going to be 1 times 3 times 2 times 3. 1 times 3 is 3. 3 times 2 is 6. 6 times 3 is 18. That's all there is to it. Now, let's see why that's true. I can expand about any column or any row. So I choose to use row 4. Now 0 times its cofactor is 0. 0 times its cofactor is 0. 0 times its cofactor is 0. So I only have 3 times its cofactor. Well, its cofactor is going to be -1 to the 4 plus 4 times the minor, which is what I would have if I take out row 4, column 4. So if I take out row 4, column 4, I'm left with 1, 2, 1, 0, 3, 2, 0, 0, 2. So that's going to be 3 times this one. Now, so it's going to be 3 times, to evaluate this, I'm going to expand around row 3. Well, this would be 0, this would be 0, so it's going to be 2 times a negative 1 to the 3 plus 3 times the determinant if I take out row 3, column 3. So that's going to be 1, 2, 0, 3. So this is going to leave me with 3 times negative 1 to 3 plus 3 is negative 1 to the 6th, which is positive 1, times 2 is 2, times 1 times 3 is 3, minus, that would be 0. So if you look, we have 3, 2, 1, and 3, which is 3, 2, 1, and 3, which is multiplying down the diagonal. So that would be 3 times, 1 times 3 is 3, and then 2 times 3 is 6, 6 times 3 is 18. So you can see why, if we have a triangular determinant, that all we need to do is to multiply along the diagonal. We end up with the same numbers because we'll always expand around the row that has the zeros.